Good morning to one and all present here. Today we're going to discuss my project, which is on portfolio forecasting using neural networks, LSTMs, and its optimization. I'm Akhil Sanjay Poddar from the University of Oklahoma. Let's get ahead. So in this project, we are attempting to perform portfolio price prediction using LSTMs, along with the optimization of the portfolio using Monte Carlo and SciPy optimizers. Uh, this project is it aims to be a tool for an amateur stock trader to use in his or her trading or investment activities. So for this project, I have used a diversified portfolio of 5 stocks. They include 2 tech companies such as Google, Tesla, 2 mutual fund companies such as Vanguard 500 and S&P 500, and a non-traditional stock that is the water stock, American Waterworks. So we will be using the forecasts. We'll be checking, we'll be using the models to get the forecasts for these stocks, and we'll be able to identify some trends, then thereby take calculative decisions whether to invest further based on the various factors such as risk, growth, stability, and so forth. So the project I've divided is into 2 parts. Part 1 focuses on the stock price prediction using the neural networks, and the part 2 focuses on portfolio optimization. So in the part 1, we use LSTMs because uh, they have a data prior layer as a memory, and because of which they are widely used for sequence prediction problems and thereby time series prediction. Uh, Furthermore, portfolio management uh, in the part 2 is done using Monte Carlo and SciPy optimizers, which uses brute force to determine the best result in the neighborhood. Uh, this actually focuses on minimizing the Sharpe ratio, which we will be discussing in the coming slides. Just a quick note on LSTMs. LSTMs, they're a part of, they're a kind of recurrent neural networks, and they are extremely helpful in any kind of time series prediction and even in text analysis. So the data set that we have chosen is from the Yahoo Finances, yahoofinance.com. We have, again, as I said previously, we have 5 stocks. I've made it diversified so that we don't have our risks also diversified from the beginning. This was an intuitive call. So 2 tech companies, Google, Tesla, Vanguard 500, S&P 500 mutual funds, and the water stock, the American Waterworks. Uh, so the data comes in multiple with multiple variables, that is date, open, high, low, close, and volume. As you can see in the data frame given below, open and close represent the starting and the final price for which the stock is traded in the day. A high and low represent the maximum and the minima for the day, and volume is the number of shares bought or sold in that current day. Over here we see the Tesla stock price history. This is just to show you how upon visualization of this data frame it is seen. So you see the open, high, low, and the close uh, lines. Fun fact, we will be using uh, the close values for predictions in the future. It's because knowing the closing values gives us a better estimation for the next day's uh, investment. So, as said earlier, in the we have few steps in the stock price prediction uh, in part 1. The first part is data visualization and exploration. Uh, the profit or loss calculation is usually, as I said, determined by closing price of a stock for the day, and we will be using that for our prediction in the future. Uh, This is another representation of the volume of the stock. As you can see, the AWK stock volume history, it seems that there has been a certain spike at 400. This, upon further investigation, may yield a fact of how sentiment analysis into the news, Twitter, elsewhere would have affected this rise in the volume. Uh, Continuing the steps in part one, the step two is the division of the training and the test. That is 80:20 ratio for the train and test division of the data was done. Now, test data here indicates is a validation set to see if the model perfectly validates the data. It's because we need to keep a certain part of the data uh, away from the model to see how good it functions. And I have kept around 8 months of the data, 252 days away from the model so that I can predict and see how good it actually is. Uh, so the normalization of the data is also an important fact because it helps in the converging of the local and global minimum. Uh, there is a package called, there is a function called min-max scalar from the scikit-learn package, which I have used for normalization. Furthermore, I then converted the data to a time series and supervised learning problem by generating time steps. This shows us how many units back in time my network can see so that I can retain information of the prior 2 months of data to predict the next day's price. Also, in this step, I also do NumPy transformation, which helps me feed my data into the LSTM. The time step is an important fact as it stores the data for the prediction. Stock forecasting. Again, step 5. So then we create neural networks in Keras. We used LSTM function from the Keras package, and we just got 3 layers, 2 LSTM layers with 50 units each, and a dense layer in the output. Uh, we then perform model fit, uh, and we just train it for one epoch, just with a batch size of one. It's because uh, we just want to see how it functions natively, and then after that, if there are no good results, you can do hyperparameter tuning from there on. Uh, the optimizer is Atom, and the measure of accuracy we are using is mean squared error. So in the sixth step, training, predicting, and visualization, the metric being the mean squared error through the Atom optimizers helps us get the RMSE values for the prediction. This indicates the absolute fit of the model to the data, how close it is to the observed data points, and the model's predicted values. Uh, it is a measure of absolute fit, and as a rule of thumb, lower RMSE value is better. So as you can see over here, we are predicting good results through the RMSE, that is, through the RMSE, we are understanding that our model is predicting good for AWK, American Waterworks, and SAP 500. The worst is being performed for Google, that is with an RMSE of 29.5894, and Tesla is the fourth, and the third is uh, Vanguard. So I've just brought this up to show you how each one of the stocks is being predicted for by the LSTM models. And as you can see, I'm sorry, the font is very small. I was hoping to maximize it. Uh, the AWK over here is having a very good prediction, although you can see a small space here in between. Although you can see a small space here in between, it has good RMSE value. Uh, Again, Google uh, is shown to have the lowest RMSE value as seen over here, and that is because its ups and downs are not being properly seen by the model. It's not a simple model. Again, Tesla over here, Tesla, it again has its uh, ups and downs which are not being properly monitored by the model, and hence they are giving a bad RMSE. And this is the others. This is the SAP and this is the Vanguard. They're doing pretty good. Moving on. So now we get back to the second part of uh, the portfolio analysis, that is the optimization. Over here, we're just seeing data trends of the stocks that we have, AWK, Google, SAP, Tesla, and Vanguard. Uh, as you can see, Google has the highest price in dollars, and that's why the other stocks are getting normalized here. And this is the daily returns and the volumes you can see. And again, Tesla and Vanguard are having high uh, movements in the volume. This is just a visualization tool to let you see how your portfolios are doing over the current years. The correlation analysis. Uh, so this is a primary stock exploration technique to check the company's performance with one another. What we are doing is over here, we are correlating the returns. There is a function, pandas data framework PCT change. This function calculates the percentage change from the immediately previous row and forms this matrix. As you can see, the diagonal is all one since there is no change between the own company. And moving on. Again, there's another part of correlation analysis. Over here, we are doing a scatter plot and we find the kernel density estimation. It is a non-parametric way to estimate the probability density function of a random variable. Uh, it determines whether your chart is more normally distributed, whether it's leaning to left, center, or right. If it's left, it's the returns in the future will have a high probability for being negative. If it's in the center, 0, and if it's the right, high probability for being a positive return. And these are the peaks that you can see. This also shows correlation, which is through the scatter plot, but it'll be much better shown in the next slide, which is a heat map. This is a correlation analysis, a heat map. To prove the correlations, we use heat maps. We visualize the correlation ranges amongst the competing stocks. Lighter colors are directly proportional to higher correlation, and the dark colors have very low correlation, as we are seeing between Amazon and Tesla over here, and Amazon and Google over here, which have the more darker shades in color. And this may not show causality, uh, but then there can be a linkage between them in the portfolio, which we will see later. So now coming to the uh, stock return rate and risk. This is part of the optim. This is where we lead into optimization. The previous part was just exploration and seeing how your portfolio is. Now, in this chart, you can see the risk versus expected returns. Risk is the uh, uh, variability and expected returns. As seen, Tesla has a very high risk and compared to the others, while its returns are not that high. And hence we can kind of, it is a function by itself wherein the risk return tolerance for the portfolio is generated. A line can be derived, this is just a random line, by which we can differentiate between buy and sell. And this is the importance of uh, a risk return tolerance in the portfolio to see where your stocks lie and what can you do with them, whether you want to hold them, whether you want to sell them, whether you want to go into buying or what. And this is just a preliminary understanding, but it gives you a very good picture nonetheless. Now coming to the final part, the optimization. Uh, so the methodology behind this is that the portfolio weights that would match the optimal, that is the highest Sharpe ratio, uh, and have the mean variance optimal portfolio is the best portfolio. As seen, Sharpe ratio is the ratio between the difference in the expected return of the portfolio investment with the risk-free rate by the standard deviation of the portfolio returns. Sharpe ratio is what we are trying to maximize in our portfolio over here, and uh, while doing that, we are also trying to minimize the variance for the portfolio. Uh, as you can see, we are using two methods: Monte Carlo brute force style optimization and SciP's optimize function. That is for minimizing. We use it for minimizing objective functions, and in our case, we can minimize the negative Sharpe ratio. That is thereby maximizing the Sharpe ratio. There are the steps in doing so. We calculate mean returns, covariance matrix of our list of stocks, set the risk-free rate required for the calculation of the Sharpe ratio that should be provided at an annualized rate. Then we calculate the annualized return, annualized standard deviation, and annualized Sharpe ratio of the portfolio through a function. The portfolio of 5 stocks is augmented with 1,000 simulations, the brute force method, to produce results. Now these results are plotted, and both the optimal portfolio with the highest recorded Sharpe ratio and minimum variance portfolios are displayed. The minimum variance portfolio is the one with the lowest recorded variance or volatility. As seen over here, the Monte Carlo method begets two types of portfolio, one in which there's maximizing of the Sharpe ratio, and another wherein we are minimizing the variance. And as you can see over here, uh, we have a Sharpe ratio of 1.32, 1.34, which is the highest amongst all in the environment, and the standard deviation as such, and the returns as such. Uh, Same for the minimum variance, we see this, and the SciPy optimize as well begets us similar results. And you can see over here that the stock weights of the portfolio along with annualized returns, annualized standard deviation, annualized Sharpe ratio. Uh, Now in this picture you can see that the American Waterworks has the highest weight in the optimized portfolio, which has a higher credibility than Tesla with respect to the weights in this model. We'll be discussing the results in the coming slides. The Monte Carlo method begets this efficient frontier seen over here, and the green one is for the minimum variance, uh, and the red one is for the maximum Sharpe ratio. As you can see that when we maximize Sharpe ratio, and returns also increase over here. Uh, and this is a way in which we get to know the optimal performance. Now, conclusions. As shown before, these are just tools to get a fair picture of your investments in the stock market. In the above example, it might be a very shocking revelation that a non-traditional stock such as a water stock has a higher weightage in the optimized portfolio, and that the Vanguard 500 is also a good investment choice. But in comparison with the tech companies such as Google and Tesla, this stood out very nicely. Uh, this can be a very eye-opener for people who just want to investigate certain stocks with retrospect with each other. Furthermore, although the conclusions have said that Tesla is bad in the long run, one must also consider sentiment analysis that has not been included in this project. Furthermore, the LSTM models can also help a client analyze his portfolio for trading practices. However, with caution, even till date, no machine learning model can correctly predict all the price movements all the time. With the tools at our disposal, the trader can also include this for further validity into his practices. Having said that, one must always follow their instincts upon reading of the various information available, and only then take a stand. And I hope that this project gives a nice insight into how portfolios can be managed, how a trader can use simple tools like these to have a much better insight into his or her trading activities. And that'll be all. Thank you so much. Have a good day ahead.